Good morning, good morning, good morning. Let's make sure this volume is good today. I didn't realize how low it was previously. My apologies about that. Wasn't able to document my day two, but I'm going to redo it today. But hope everyone's doing well. Just looking to for this morning stream session. Just looking to get some of my daily cybersecurity learning in. I didn't jump on last night. Had a rough night, but we are going to lock in this morning here for a couple hours. We'll take a step away, and then I'm going to talk about some mindset topics that I like to discuss that I primarily do on my channel. And then later on this evening, I'll probably come back and work on a little personal side project. I haven't heard back from my friend of mine just yet about updating his domain for the website that I did for him. But once he does, and I update it for him, once he gets his domain secured and I update it for him, then I will share that with everyone and try to talk about the stack and how I built it and some of the trade-offs I made in order to make sure he has a good experience and also his clients have a good experience. But as I mentioned, just looking to learn, document my journey today with cybersecurity. Today, it looks like we're putting it all together. Prior to today, we started with introduction to cybersecurity, and I'm on tryhackme.com. I did go ahead and sign up for the paid tier since I do intend to see this thing through, and eventually I'm going to take the Google cybersecurity. I'm gonna go get that certificate. I don't know if what I'm going to do with it, but I do want to have it and say that I learned it and really kind of help it allow me to become a better developer, programmer, etc., and maybe even venture into cybersecurity. But I just love solving problems. And one of the things I picked up pretty quickly with it is that it's all about solving problems and critical thinking and things of that sort. So this is kind of like I didn't realize it was this involved. It's pretty intriguing. And I've skipped around a little bit more than what's just on this. This is just the formal structured learning. Obviously, I've done some things on my own to kind of help supplement that because I'm kind of ready to get into the fun stuff, if you will. But I intend to maybe do something with it professionally, but at the very least, I'm going to make sure that I secure my applications and my network a lot better. And if I decide to do something with it on a full time or formal basis, I'll certainly update you. But with that said, day one was introduction to cybersecurity, and then from there I jumped into network fundamentals, and then now I am on how the web works. Prior to, we talked about DNS, HTTP, how websites work, and then putting it all together. That's what we're going to do today. And then the next one I'm looking forward to is Linux fundamentals. It's been years since I've touched Linux, but I am looking forward to it, and we'll talk about it. And I may even see if there's a way that I can get a little bit more practice with it so that I can be a lot more efficient with it, because I do miss working with it. It's been a while since I've had to work with it, but I'm looking forward to getting back into it. And I actually enjoyed it now that I think about it, my experiences with it. So we'll see kind of how it goes from there. But looks like this section is starting off with a video indicating of putting it all together. I'm just going to briefly listen to some of this. I kind of struggle with watching tutorial videos at this point. They have the documentations here, so I know I'll be reading those, but I'm just going to just see what's talked about in the video since it is included in the lesson, and I don't want to cut corners, if you will. But let me know how you're doing. For those that are out there, I would love to just see how you're doing and say good morning and hello and learn where you are checking in from. Fairly familiar with this coming from web development, but always always here to pick up a tip or two. familiar with load balancers. Yeah, it is. Familiar with that as well. Yeah. Hmm. All right, I'm gonna stop there because I don't want to hear the questions or the answers. Rather, we'll go ahead and join this room. All right, so putting it all together from the previous modules, you've learned that quite a lot of things go behind the scenes when we request a web page in your browser. To summarize the request websites, your computer needs a server IP address, which we're aware of. It talks to. For this, it uses the DNS. Your computer then talks to the web server using a special set of commands called HTTP. The web server then returns HTML, JavaScript, CSS, images, etc., which your browser then uses to correctly format and display the web page to you. So a structure that pretty familiar with based on prior experience, but always good to get a refresher and an update. Nothing wrong with that. And we'll dive into the other components section now. Load balancers on a website, traffic gets quite large or is running an application that needs to have high availability. One server might no longer do the job. Load balancers provide two main features: ensuring high traffic websites can handle the load and providing a fail if a server becomes unresponsive. Pretty familiar with these. Don't know if anyone has any experience with building websites that might have suddenly experienced a high amount of traffic than what it intended or what it was built for. But this is a pretty unique experience if you have had opportunity to experience anything with it. But they provide two main features, ensuring the high traffic websites can handle the load and providing a failover if the server becomes unresponsive. When you request a website with the load balancer, the balancer will receive your request first and then forward it to one of the multiple servers behind it. Okay. The load balancer uses different algorithms to help decide which server is best to deal with that request. And that part can be configured, but I think it also does a lot of it out of the box as well too. But depending upon what you go with, it can be configured so you can determine where it goes in the event it does experience a sudden high amount of traffic. A couple of examples of these algorithms are round robin, which sends it to each server in turn, or weighted, which checks how many requests a server is currently dealing with and sends it to the least busy server. Okay. Load balancers also perform periodic checks and each server to ensure they are running correctly. This is called a health check. If a server doesn't respond appropriately or doesn't respond, the load balancer will stop sending traffic until the server is appropriately up again. So this kind of lends back into those scenarios where someone may say we have a server down, and the load balancer could be one of the first indicators to kind of help with that. You should have other checks in place to help with that, but a load balancer is there to help in those scenarios. So that is a another benefit of it as well. A CDN, content delivery network, will capture that. Let me know what it is, but wouldn't help to have it. Wouldn't hurt to have it. Content delivery network. Uh, can be an excellent resource for cutting down traffic to a busy website. It allows you to host static files from your website, such as JS, CSS, images, videos, and host them across thousands of servers all over the world. When a user requests one of the hosted files, the CDN works out where the nearest server is physically located and sends the request there instead of the potential other side of the world. So this is all about making the network more efficient so that it leverages the nearest location and it's not trying to send your traffic all over the world or somewhere that's going to take longer to respond. Helps the city send traffic to the nearest physical sub. Ooh, I can't spell this. Physical located server instead of potentially across the world. Okay. Databases. Often websites will need a way of storing information for their users. Web servers can communicate with databases to store and recall data from them. Databases can range from just a simple plain text file up to a complex cluster of multiple servers, providing speed and resilience. You'll come across some common databases: MySQL, Microsoft SQL, MongoDB, Postgres, and more. Pretty familiar with databases coming from the web development space. That's something that you work with just about on a daily basis. But there are different types of databases, and there are some that are leveraged for different things based upon your application and the end user or the stakeholders' needs, if you will. So, very familiar with MongoDB, MySQL, Postgres, even leveraging a ORM to kind of help query and mutate that data. But pretty straightforward for this, what we're learning right now, just kind of bringing it up as a knowledge check or a relevant point that they do exist, and this is part of things that have to be secured because this is where customer sensitive data is stored. Next, we have a WAF. which is also known as a web application firewall. This sits between your requests, your web requests, and the server. Sits between the web requests and web server. Primary purpose is to protect the web server from hacking or denial of service attacks, analyze the web request for common attack techniques, whether the request is from a real browser rather than a bot. It can also check if an excessive amount of web requests are being sent by utilizing something called rate limiting, which will also allow a certain amount of requests from an IP address per second. If a request is deemed a potential attack, it will be dropped and never sent to the web server. So another added layer of security, two things mentioned there: a firewall, a web application firewall, which is designed to protect the servers, as it mentioned, um, and also a rate limiter, which we're familiar with, which doesn't allow but so many pings or updates from a website, I should say, within a certain amount of time. If it receives a certain amount, it's going to block that IP address from being able to communicate with our server, which is a good thing. It's another mechanism of security, and it is absolutely a necessary thing to include. What can be used to host static files and speed up client visits to websites? CDN. What does a load balancer perform to make sure a host is still live? What term did it use? Load balancer perform. It should be rate limiting. No. A load balancer. Mm, to make sure a host is still alive. Health check. What can be used to help against the hacking of a website? Oh, I was going to say firewall, but we'll call it WAF. Cool. All right, let's keep it going. How web servers actually work. So I think we're at that part in the video, and we'll listen to it first. He stumbled reading it itself. Pretty familiar with a lot of this already, but I'm just going to read over it from this perspective. Looking forward to that. All right, we'll stop there. I don't want to get into the question. So, what is a web server? Software that listens for incoming connection that utilizes the HTTP protocol. Software listens for connections. The most common web server software you'll come across is Apache, Nginx, IIS, and Node.js. The web server delivers files from what's called its root directory, which is defined in the software settings, something we have some experience with. For example, Nginx and Apache share the same default location of var, www, HTML. In Linux operating systems, and ISS uses the C and then the appropriate path for Windows operating system. So for example, if you requested the file HTTP example.com, it would send the file var www to the local hard drive. Makes sense. The next term is virtual host. Um, Web servers can host multiple websites with different domains. To achieve this, they use virtual host. The web server software checks the host name, begin requests from HTTP header, and matches that against its virtual host. The virtual hosts are just text-based configuration files. If it finds a match, the correct website will be provided. If no match is found, the default website will be provided instead. Okay. So basically, it's going to try to initially launch what you requested. If nothing is filed, it's going to refer back to the default website. So that is a safe mechanism in place. Virtual hosts can have their root directory mapped to different locations on the hard drive. For example, 1.com being mapped to var www website underscore 1, and 2.com being mapped to var var www website underscore 2. Okay. There's no limit to the number of different websites you can host on a web server. Virtual host servers can host changes. Web servers can host multiple websites with different domain names. This is called VH. All right, so static versus dynamic content. Very straightforward. Static content, is the name suggests, it's content that never changes. Yep. Common examples of this are pictures, JS, CSS, etc. But can also include HTML that never changes if you're hard coding something into the HTML. Furthermore, these files that are directly served from the web server with no changes made to them. Dynamic content, on the other hand, is content that could change with different requests. Take, for example, a blog. Of course, you'll continually update a blog. You have people make comments, likes, things of that sort. On the home page of a blog, it will show you the latest entry. Yep. If a new entry is created coming from the back end, this home page is then updated with the latest entry. Or a second example might be a search page on the blog. Depending upon what word you search for, the results will be displayed. These changes to what you end up seeing are done is called the back end, where the use of programming and scripting languages is called the back end, because what is being done is all being done behind the scenes. Yep. You can't view websites HTML source and see what's happening in the back end, while HTML is result of the processing from the back end. Everything you see in the browser is called a front end. Pretty straightforward. I'm not going to spend too much time on that. Scripting and backend languages, there's not much of a limit to what a backend language can achieve. And these are what make a website interactive to the users. Some examples of these languages in no particular order: PHP, Ruby, Python, Node.js, Perl, and many more. These languages can interact with databases called external services, process data from the user, and much more. A very basic PHP example of this would be if you requested the website example.com, and here's what it's built like. It will output the following to the client: hello, because it is getting the name of the person and then just greeting that person. You'll notice that the client doesn't see any PHP code because it's on the back end. This interactivity opens up a lot more security issues for the web applications that haven't been created security. We'll learn more about it later. Makes sense. What does a web server software use to host multiple websites? This would be a virtual VERT. Did I spell that? VEVIRTUAL host. What is the name of what is the name for the type of content that is being changed? Oh, dynamic. Is that what you're looking for? Yeah, it looks like it. What does the client see? Does the client see the back end code? Nay. Cool. Yeah, I figured it wasn't gonna get too in depth with that, so didn't need to capture too much from it. So we got a quiz. We have a quiz. View the site. We gotta do some work. Button on the right, using everything you've learned from the other modules, drag and drop the files into the correct order of how a request to a website works to reveal the flag. When placing a tile in the correct position, it will highlight in green when the tile is wrong. Okay. All right, so where we at, baby? Let me see, I might need to refresh the page. Okay, yeah, she just spin there. This is a very cool platform. I may attempt to build something of my own, a condensed version, of course, but this is very, very cool. Having a virtual desktop and all of that good stuff. Where's the flag? Well, not the flag, but where's the content? Well, I hate to do that, but the site isn't even up, so it's kind of hard to take the quiz if you don't have a challenge there for me to work through. Yeah, see, it's not giving me this. So it should start with the browser making a request. No, it just said render. So it should be a request on the website. Yep. And then the next would be to find the web server. Request from the website. All right, so hold on. Yeah, it's still not showing anything. Yikes, that's the first time that didn't work. But we're gonna learn either way. Request from websites. It should be. I can't see all of them. Yep, make a request first. So then it will check the local cache. If it's already made this request, it's just going to leverage what it already has. So it's not, if the website is optimized, and I'm not gonna get too much into this because this isn't a web development course, but if it's already optimized, it's going to leverage what's already there in the cache. So it's not making another request to the server because it should already be stored in the cache. So it'll check the query root server to find the authoritative. No, first it checks your recursive DNS server for the address. If not, it will query the root server to find authoritative DNS server. Yep. Authoritative DNS server advises the IP address for the website. Then the request will pass through a firewall, through a web app firewall. Then passes through a load balancer. And then from there, it will connect to web server on port 80, of course, if it is successful, or 443 if it is secure. Yep. All right, so this is what I'm looking for because, man, the thing didn't pop up. You got the order. Let me see if that's it. THM U underscore got underscore D underscore order. Man, I would have preferred to go through it myself, but it didn't it didn't come up. I hope that's just a one-off and it doesn't happen again. It's been a one-off so far, but this has been great thus far. And I'm getting alerts of all these little badges. Thank you, thank you, thank you. Thank you. All right, so we've completed Introduction to Cybersecurity Network Fundamentals, how the web works. Now let's get into Linux. This should be fun. We'll start with the video. Mm-hmm. Nice. some familiarity with that, but it's been a while, so it'll be fun. '91. All right, let's jump in and read up on Linux. Where is Linux used? It's fair to say that Linux is a lot. Let's see what my baby girl sent me. Ah, this is pretty cool. This. I'm sorry, my daughter texts me. It's my boo. One of my boos. I got two of them. It's one of my boos. All right. She in biology class. All right. Is it fair to say Linux is a lot more intimidating to approach than operating systems such as Windows? Both variants have their own advantages and disadvantages. For example, Linux is considerably more lightweight, and you'd be surprised to know that there's a good chance you've used Linux in some form or another every day. Linux powers things such as websites you visit, car entertainment control panels, POS systems as checkout tills and registers in shops, critical infrastructure such as traffic light controllers or industrial sensors. Flavors of Linux. It is actually an umbrella term for multiple operating systems that are based in the UNX, another operating system, UNIX. Thanks to Linux being open source variants, Linux comes in all shapes and sizes. For example, Ubuntu and Debian are some of the more commonplace distributions of Linux because it is extensible, i.e., you can run a Ubuntu as a server, such as a website or a web application, or as a fully fledged desktop. For this series, we're going to be using Ubuntu. Perfect. All right, we're gonna take my man's answer, and the operating system was first released in '91. All right, so let's check out what he's covering next. Perfect. Mm-hmm. Hmm. Yep. Okay. Let's see. So hello world. All right, let's get to it. All right, so interacting with your first Linux machine. Let's go ahead and click on Start Machine. We'll give it just a moment. Probably could have done that while I was just reviewing the content. Hey, we got a recognition. We got recognition. Whoop, whoop, whoop. It's in the process of inquiring our IP address, which I don't know if we'll need that or not, but it'd be good to have. And I know this is a virtual environment, so this is pretty cool as well. Still going. All right. All right. So this room has a Ubuntu Linux machine that you can interact with all within the browser, following along with this room's material. However, to get started, simply press Start Machine. Once deployed, a card will appear at the top of the room. Yep. This contains all of the information for the machine deployed in the room, including the IP address, the expiry time, along with buttons to manage the machine. Excuse me. Remember to terminate the machine once you are done with this room. More information. Yeah, we'll take care of that. For now, press Start Machine, and you'll be able to interact with your own Linux machine within the browser, following along with this room. Yep, I've deployed it. Okay, next, running our first few commands. As previously discussed, a large selling point of using an OS such as Ubuntu is how lightweight it can be. Yep, this of course doesn't come without its disadvantages or trade-offs. Where, for example, often there is no GUI, graphical user interface, or what is known as a desktop environment that we can use to interact with the machine. Yep. A large amount of interacting with systems is using the terminal. The terminal is purely a text base and is intimidating at first. However, if we break down some commands, after some time, you'll quickly become familiar with using the terminal. We need to be able to do some basic functions like navigate the files, output their contents, and make files. The commands to do so are self-explanatory once we know what they are, of course. Echo, output any text we provide. Well, who am I? What user is currently logged in as? As shown in the terminal above, if we want to echo a single word, we don't need to use double quotes, for example. We could just say, and it gave me back hello. Cool. Who am I? Who am I? TryHackMe. Okay. If we wanted to output the text, TryHackMe. Output the text, TryHackMe. We would go echo TryHackMe. Check. What is the username of who you're logged in as on your deployed machine? TryHackMe. Okay, cool. Excuse me.
And let me go ahead. I'm going to clear my terminal on the right-hand side. This is done with Control and L. So I'm holding down Control and then hitting L, and that clears the screen. Pretty nice. Whilst knowing about the existence of files is great, it's not all that useful unless we're able to view the contents of them. We will come back to discuss some of the tools available to us that allows us to transfer files from one machine to another in a later room, but for now, we're going to talk about simply seeing the contents of text files using a command called cat. Cat is short for concatenating. It is a fantastic way to output the contents of files, not just text files. Actually, cat will, even if you have binary files, so things like executables on Windows or things that you would run, it will do its best effort to display everything in that file. You'll get a lot of random, just garbage text, but you can definitely see what's in the file. So, just something to be aware of. In the screenshot below, you can see how I combined the use of ls to list the files within a directory called documents with cat right over here. So we've listed the files, and then we've used cat on this file to list out what's in it. We've applied some knowledge from an earlier task to do the following. We've used ls to let us know what files are in the documents folder of this machine. In this case, it's called todo.txt. And then we have then used cat and then todo.txt to concatenate/output the contents of this todo.txt file. Where the contents are, here's something important for me to do later. Pro tip, you can use cat to output the contents of a file so you don't actually have to navigate to that file. You can use what's called the absolute path. Don't worry too much
Yeah.
about this right now, but this is the full path from the root of the file system, which we'll cover later, to the actual file itself. Sometimes things like usernames, passwords, yes, really, this does happen a lot. You'd be surprised what you can find. It's the equivalent of finding sticky notes on people's desks, and it happens a lot. Flags or configuration settings are stored within files where cat can be used to retrieve these. Cat will be your best friend, and trust me, you will be familiar with that command in no time flat. Finding out the full path to our current working directory with pwd. You'll notice as you progress through your navigating your Linux machine that the name of the directory you're currently working in will be listed in your terminal. So in this case, it's not listed right now, but if I were to cd into folder 1, we can see that it's listed right here at the start. So we are in the folder 1. However, if I go back to my home directory, which is just, think of your directory that the desktop, the pictures, and all that are in Windows, that is your home directory. And you can see that we just have our normal group of files here for this specific example machine. But we can see that it's displayed here on the front of the terminal. However, it's easy to lose track of where we are in the file system exactly, which is why I want to introduce PWD. This stands for Print Working Directory. I often remember this by Present Working Directory. However, print is the correct one. Whichever one works for you to remember it, this is something that you'll pick up on very quickly with practice. Using the example machine from before, we are currently in the Documents folder. But where exactly is this on the Linux machine's file system? We can find this out using the pw command like within the screenshot below. And we can see that we've done that down here. Let's go ahead and use pwd, and we can see where we are on our example machine over on the right. And we can see that we're in TryHackMe, that user's home directory. Let's break this down. We already know we're in the documents thanks to our terminal, but at this point in time, we have no idea where documents is stored at so that we can easily get back to the features. So we can see we're in the documents folder up here. I've used the pwd command to find the full file path of this documents folder, which we did right here, and we're returned the full path. We're helpfully told by Linux that this documents folder is stored at home Ubuntu documents on the machine. Great to know. Now in the future, if we find ourselves in a different location, we can use cd home documents Ubuntu documents to change our working directory to this documents directory. Let's dive into the questions.
All right, we're not gonna do that. All right, let's go to, we're done with this one. Let's go to interacting with the file system. So far, we've covered echo and who am I commands. Not all that useful when you consider things that we need to do, including navigating the file system, read and write as well. In this task, we're gonna be learning the commands so that we can just do that. Just like in the previous, I'll display the commands in the table. In the next heading and show examples. So some of this is pretty But we'll just take notes. LS is listing, CD change directory, cat is concatenate, and PWD we already have. Listing files in our current directory. Before we can do anything such as finding out the contents of the files and folders, we need to know what exists in the first place. This can be done by typing ls folder 1234. In the screenshot above, we can see that there are following directories: important files, yep, my documents, notes, pictures. You can probably take a guess as to what to expect in a folder contains given by its name. Yep. And that's the contents of the directory. That's the contents of the directory without having to navigate to it. Let's go ls folder 1. Look like it's empty. Yeah, they're empty. Okay. Just want to see what it'll give me. No biggie. All right, now that we know what folders exist, we need to use the cd command to change the directory. Say if we wanted to open the file, open the pictures directory, I do cd pictures, where again, we want to find out the contents of pictures directory and do so by using ls. So in this example, the pictures folder has a picture of dog, 1, 2, 3, 4 pictures of a dog. Outputting the contents of a file. Knowing about the extent of a file is great. It's not all that useful unless we're able to view the contents. Yep. We will come on to discuss some of the tools available to us that allows us to transfer files from one machine to another in a later room. But for now, we're going to talk about simply seeing the contents of text files using the common command cat. All right, we are back. All right, so knowing about the existence of files is great. It's not all that useful unless we're able to view the contents of them. We will come to discuss some of the tools available to us that allows us to transfer files from one machine to another. But for now, we're going to talk about simply seeing the context of the text files using a common command called cat. Cat is short for concatenating, and it's a fantastic way for us to output contents of file, not just text files. Okay. In the screenshot below, you can see how to combine the use of ls to list the files within a directory. Okay. We've applied some knowledge from earlier in this task to do so. Use ls to let us know what files are available in the documents folder of the machine. Yep. In this case, it's called todo.tx. We've used cat todo.tx to concatenate the output, to concatenate slash output the context of the todo.txt file, where the contexts are, here's something important to do later. Okay. It's pretty straightforward. Basic terminal commands translate to Linux, but just want to go through the process, finding out the full path to our current working directory pwd. You'll notice as progress through navigating your Linux machine, the name of the directory that you're currently working on will be listed in your terminal. So when we typed pwd, it just shows that we're in the directory of home/trackme or TryHackMe, excuse me. Using the example from before, we're currently in the documents folder, but here is this exactly on the Linux machine file system, where, excuse me, we can find this out by using pwd as in the screenshot below. Let's break it down. We already know we're in the documents. We're in documents thanks to our terminal. But at this point in time, we have no idea where documents is stored, so that we can go back and easily in the future, go back to it easily in the future. I have used pwd command to find the path of this documents folder. We're hopefully told the Linux that the documents directory is stored at home. You've been to documents on the machine, which is great to know. Now in the future, if we find ourselves in a different location, we can just cd into that directory. On the Linux machine that you deploy, how many folders? 4. Which directory contains a file? That's a very good question. So I tried, let's see, folder 3, ls, folder 4, 4, folder 4, and it has the note.txt me. What is the contents of the file? Um, let's see. What I do need to figure out is the contents of this file. Hello world. Mm, cool. Next, searching task 6, introduction to shell, conclusions, and then summary.
On the Linux machine you deployed, how many folders are there? And we can see that there are 4 folders. There we go. Which directory contains the file? So we've gone ahead and already looked in folder 1 and folder 2. Let's take a look in folder 3. And of course there's nothing. Of course it's the last one. Let's do ls folder 4. And we have note.txt. So that's going to be folder 4. Wouldn't it be funny if there were no files in any of the folders? That'd be great. What are the contents of this file? Let's go ahead and cat folder 4 note.txt. And it looks like it has hello world. There we go. Use cd to navigate to this file and find out the current working directory. What is the path? Let's go ahead and cd folder 4 and then use pwd to find our current working path. And we can see that it is home TryHackMe folder 4. There we go. Let's move into task 6, searching for files. Although it doesn't seem like it so far, one of the most redeeming features of Linux is truly how efficient you can be with it. With that said, you can only be as efficient as you are familiar with it, of course. As you interact with operating systems such as Ubuntu over time, essential commands like those we've already covered will start to become muscle memory. One fantastic way to show just how efficient you can be with systems like this is using a set of commands to quickly search for files across the entire system that our user has access to. No need to consistently use cd and ls to find out where things are. Instead, we can use commands such as find to automate things like this for us. This is where Linux starts to become a bit more intimidating to approach, but we'll break this down and ease you into it. That being said, one quick meta note, find here works a lot better than Windows search. This is actually worth learning, and there's an entire dedicated room to this. You can see a note down here for that. I do highly recommend doing this room, especially after you've completed the Learn Linux series. It is one of the most insightful rooms on TryHackMe, especially for learning a critical command, so I highly recommend it.
We will do it
Using find. The find command is fantastic in the
using
sense that
find.
it can be used both very simply or rather complex, depending on what exactly you want to do with it. In fact, so much so, we have an entire dedicated room, as I mentioned before. However, let's stick to the fundamentals first. Take the screenshot below. We can see a list of directories available to us, and we can see that up here. We have our directories listed out here as well. Now, of course, directories can contain even more directories within themselves, so you can have recursion there, and you can very quickly lose things,
We're gonna read
See
through
that coming as
this.
well.
Make sure we take some
At
good
least you
notes.
already know that too. That wasn't so tough, huh? Using grep. Let's take a look at grep. This is one of the most important tools as well that you'll want to learn with moving forward in analytics. This is a tool that, especially as you're learning to do CTFs and other challenges, grep is going to become your best friend. Another great utility that is a great one to learn about is the use of grep. The grep command allows us to search the contents of files for specific values that we are looking for. Take, for example, the access log of a web server. In this case, the access.log of a web server has 244 entries. That's a lot of lines. That is a lot to look through, especially if you want to do this in a timely manner. Using a command like cat isn't going to cut it too well here. Let's say, for example, if we wanted to search this log file to see things that a certain user/IP address visited. Looking through 244 entries isn't all that efficient considering we want to find a specific value. We can use grep to search the entire contents of this file for any entries of the value that we are searching for. Going with the example of the web server's access log, we want to see everything that the IP address, and I'll let you read that one yourself, has visited. Note that this is fictional. However, this access log, this is actually indicative of a real log. So, great example, and this is actually something that if you are doing forensics or anything like that, or maybe a challenge to look through log files, you'll probably come across this at some point. grep has searched through this file and has shown us any entries of what we provided and that is contained within this log file for the IP. Use grep on access.log, and I need to go up a directory for that, to find the flag that has a prefix of THM. What is the flag? Let's use it.
All right. So let's jump into it. I think the next one is searching for files. Although it doesn't seem like it so far, one of the redeeming features of Linux is truly how efficient you can be with it. Excuse me. With that said, you can only be as efficient as you are familiar with it, of course. As you interact with OSS, such as you've been to over time, essential commands like those we've already covered will start to become muscle memory. One fantastic way to show just how efficient you can be with systems like this is using a set of commands to quickly search for files across the entire system that our user has access to. No need to constantly use CD and ls to find out where it is. Instead, we can use a command such as find to automate things like this for us. This is where Linux starts to become a bit more intimidating to approach, but we'll break it down and ease you into it. All right, so the command using find. The find command is fantastic in the sense that it can be used both for very simple or rather complex, depending upon what it is you want to do exactly. However, let's stick with the fundamentals first. Take the snippet below. We can use it to see the available directories to us. Okay, now of course, directories can contain more directories within themselves. It becomes a headache when we're having to look through every single one just to try and look for a specific file. We can use find to do that for us. Let's start simple and assume that we already know the name of the file we're looking for, but can't remember where exactly it is. In this case, we're looking for password.txt. If we remember the file name, we could simply go find /name. So let's do, it's Control L. What is it? Space. I'm sorry, Control L. So if we wanted to do it, we could say find name note.txt. And if we're already in the appropriate directory, so we would just do /note.txt. Cool. Find has managed to find a file. It turns out it is located in folder 1. Sweet, but let's say that we don't know the name of the file. We want to search for every file that has an extension txt. It lets us do that too. Just making some into a catch-all. Do file, name, asterisk, file type. Using grep. Another great utility that is a great one to learn about is grep. The grep command allows you to search contents other files for a specific value that we are looking for. Take, for example, the access of the log web server. In this case, the access.log of the web server has 244 entries. Woo, that's a lot. Using a command like cat isn't going to cut it well. Let's say, for example, we wanted to search for this this log file to see the things that a certain user IP address visited. Looking through 244 entries isn't that efficient considering we want to find a specific value. I agree. Use grep to search the entire contents of the file. Going with an example of web server log, we want to see anything that's an IP address has visited. So then we'll just type grep that search through the file that is notice contained using grep on access log to find the flag. Has the prefix THM. It's the flag, not the access log. So is that grep? Oh. Uh-oh, I might have broke it. Let's go Control L. THM access log. THM access. Cool. And I still haven't found what I'm looking for. Okay. Introduction to shell operations.
grep, and then we want to look for THM star, and then we want to look in access.log. And there we go. We can see that it's highlighted that operator, this is the single graded ensign. This operator is what's known as an output redirector. What this essentially means is that we're going to take output from a command we run, so output that would go to standard out, such as when we did echo hello, this will be the output right here. And take that and send that output to somewhere else. We're going to take it and move it
Yeah, I can't do it. It's boring. Okay, this command to greater than is output redirector. What this essentially means is that let's say we wanted to create a file named welcome. This operator is also an output redirector like a previous operator we discussed. However, what makes this operator different is that rather than overriding any contents within a file, for example, it instead just puts the output at the end. Run a command in the background. And to replace the contents of a file, name, passwords with password. Okay, so this does replace. I was gonna say I didn't see the word replace in it, but all right. So if we wanted to, we would do echo. Oh man, don't do that. Oh no, come back, come back, come back. Let me see, we got a 500. That's a bad request, not good. Let's refresh this. outside. Come on, baby. All right now. Yeah, yeah, yeah. Yay, yay, yay. Well, I may need to restart. Maybe they're having an issue with their server. Well, looks like I may. Here we go. There we go. Whew. Made me nervous there for a minute. I don't need to do the OSI model. Close that out. Looks like I may have to log back in, maybe. Nope. I won't, man. I won't, man. Thank you for stopping by. Ah. I'm not gonna hack you, man. I am gonna learn about it, but I'm not gonna hack you. Man, I'm having some problems with the dang on website. Maybe it's them. I'm already in the pre-security. Let's go back to the dashboard, roadmap. Darn. Yeah, we already enrolled in this. What's going on with this darn thing, man? Uh, try to access it on my phone to see if it is just my computer or if the thing is down. That was funny. Jeez Louise. Well, I know I'm gonna go back and do some practice, but I would have liked to finish out the learnings. It's all good. I may just try it on my phone. Yeah. Let's go back to the dashboard. Let's go resume learning. Okay. Well, got a little excited. See, we getting that error code 500. Failed response from the server. So maybe it is their site. I won't keep pinging it. All right, so we'll be back later on. I'm gonna try this on my phone to finish out this Linux portion, but if not, we'll jump back into it later on. But I appreciate those that did stop by and support my journey. And to those that didn't, it's all good, all love. Hey, are we gonna do anything yet? Yeah, it's all good. It's not working. It's fine. We'll come back to it. We'll come back to it later. But thanks for checking me out, though.